Hello everybody, this is Mr. Longo, and this video is going to cover how we classified triangles by either their sides or their angles. Now, by sides, we have three different kinds of triangles. We have a scalene triangle, an isosceles triangle, and an equilateral triangle. A scalene triangle means it has three different side lengths. That's what a scalene triangle does. So we have a 4, 10, 12. They add up to a grand total of 26. But that's not what they add to. It's just the fact that they have three different side lengths. Isosceles, as you can see, has two congruent side lengths. So it has two congruent sides. That's how we know it's an isosceles triangle. Now, there is something special that happens in an isosceles triangle, and that's the fact that if you have two congruent sides, you will have two congruent angles as well. And last, in terms of side classification, we have the equilateral triangle, which means all three sides are congruent. Now, again, similar to the isosceles triangle, all three angles of an equilateral triangle are going to be the same. That means you can also call this equiangular, but that would be a classification in terms of angles, not sides. Okay, so the three classifications for sides are scalene, isosceles, and equilateral. So now we're going to move on to talking about angles for classification. The first is called acute, and that means all three angles are less than 90 degrees, which is an acute angle. Now here's something very special, very important that applies to every single triangle that we will be discussing. And this is, of course, when we are talking about triangles in a two-dimensional plane, not spherical geometry. But anyway, all triangles, the three angles, sum 180 degrees. So if you did not know that before, in every triangle that we draw on a piece of paper, the angle measure will add up to 180 degrees. Example, 40 plus 60 plus 80 adds up to 180. Okay? In the second one, we have a right triangle. That means we have one right angle. And if you think about that, it makes sense because you can't have more than one. If you were to have two right angles, remember right angles are perpendicular, they're never going to meet at a triangle. They're just going to go up forever and ever and ever. So all you've done is create the bottom portion of a rectangle. So that is why we can't do that. Also, think about the fact that triangles add up to 180. If you were to do 90 plus 90, you're already at 180, meaning we don't have room for another right angle. And that is very, very similar to an obtuse triangle. That means we have one obtuse angle, or greater than 90 degrees. So that guy right there is 100. This is an obtuse triangle. Now, all of these triangles can have different combinations. We can draw a triangle that is both acute and scalene. We can draw a right isosceles triangle. We can draw an acute isosceles triangle. So there are a whole bunch of different types of combinations. That's just how you break it down in terms of sides and angles. So then we have a couple of application problems where we can use algebra and stuff like that to figure out different types of things with these properties. So now that you know what these types of triangles are, I'm going to encourage you to press the pause button on your video right now and try these two examples on your own. And then as soon as you are ready, click play and you can see if you got them correct. All right, give it a shot. So it says that we have an equilateral triangle, ABC, And it says that two of the sides are 2x plus 10, and the other one is 4x minus 20. And notice how it didn't tell me which one was which. Here's the thing. It's an equilateral triangle. It doesn't matter. All three are going to have the same length. So, since these two sides have to be the same, what we're going to do is 2x plus 10 is equal to 4x minus 20. That's the equation we will set up because equilateral triangles have three congruent sides. And then after you solve, you're going to have x is equal to 15. So now it's what we do with the 15 that's going to give us the perimeter. So once we know x is equal to 15, we can substitute it in here and find out that the length of this is 40. Now, if you're extremely confident in your algebra ability, you already know that the perimeter is going to be 120 units, because if this is 40, this is also 40, and this is 40. But to be safe, you might want to substitute 15 into here as well, which you'll get 30 plus 10 is also 40, so you know for a fact that you did it correctly. If you were to substitute it in here and get 40 and substitute in there and get 30, you know that somewhere along the way you made an algebraic mistake. Okay? So that's how we talk about number one. Number two, we have to classify the triangle by the sides. So we were not told if it's isosceles, equilateral, or scalene. But we were given all three sides, and we were given the perimeter. So for this, we have an example of add all three sides. So we have 2x plus 4 plus another side, 3x plus 6, plus another side, 4x minus 4. And we know that triangles, or any type of shape, is going to add up to the perimeter if they have straight sides. So the perimeter is 96. And all we did, like I said, is add the three side lengths. So from there, again, you're just going to combine all of your like terms. You're going to get 9x plus 6 is equal to 96. So x is equal to 10. Now once you get the 10, we have to substitute it back in and find the length of each side to classify it. So substitute it in here, we get 36. Substitute in here, we get 24. Substitute in here, we get 36. And we see that it has two congruent sides. So this is an isosceles triangle. Okay, that's it for classification of triangles. This is Longo and I'm out. See you, bye.